Welcome class. Today we're going to have a look at the next rule in differentiation. It's a very common rule that we'll use. It's called the product rule. So the notes for today, you can pause the video and copy these down. But the product rule, like the chain rule that we've done recently, the product rule is a method of differentiating. In this case, it's called the product rule because we're going to use it when we have a function that is the product of two functions. And you can see here, if y equals u dot v, now these letters u and v, when we do calculus or any differentiation, they're letters that you'll use quite commonly. So we're going to say that we've got some function that's some function u multiplied by some function v. When we first start doing this, we're going to be looking at functions. It could be like x squared, could be one of the functions, and we could have in brackets 2x minus 1 could be a second function. And so when we write a function like this, I'll just put a little red dot there, it's one function, which we're going to call u, multiplied by some other function, which is 2x minus 1, and we're going to call that v. And the way to differentiate this whole function is to use the product rule. Now you might be thinking, well, can't I just expand the brackets here and then differentiate both of those terms? For instance, if we expanded this expression, we would get 2x cubed, x squared times minus 1 will give us minus x squared. And if we then differentiate that function one element at a time, remember the 3 multiplies by the 2 to give us 6x squared, and this term here would be minus 2x. And we can do it with that method for functions like this, but the product rule becomes really powerful when we start to look at exponential functions and trig functions down the track. In this first differentiation topic, we're going to be doing it with some basic functions. But the key thing that I want you to look at today is that we have two functions that are multiplied by each other. That's when we're going to use the product rule. Now on your formula sheet, which you get to take into every assessment task, the product rule is written like this. The first derivative, if we have two functions that are multiplied and we call them u and v, the first derivative will be whatever function u is times the first derivative of v, plus whatever v is times the first derivative of u. Now there's a shortcut way of thinking about that there, where instead of writing dv dx, we're just going to write v dash, and instead of writing du dx, we're going to write u dash. Personally, and I'll show you with all the examples that I do in this video, the way I write the first derivative using the product rule is y dash, which just means dy dx, and I do u v dash plus v u dash, which means exactly the same as this. It's just a shorthand way of writing it and a really easy way to remember things. So let's go have a look at using the product rule. So we've got two example questions we'll go through here. First one, y equals 3x plus 1 multiplied by x minus 5. As I said on the last slide, we could expand that out and differentiate that, but we're going to use the product rule here. So first step in the product rule is we're going to recognize that we have two functions. We're going to call this one u and this one v. It doesn't matter at all when you use the product rule which one you call u and v, but I'm going to say, okay, well, I'm going to write y equals u dot v, and this is a way of, let's say you were doing this in a test, is showing the marker that you're using the product rule to solve this. Over to the side now, you'll come over and write where, and you're going to write u equals 3x plus 1. Directly underneath that, we're going to differentiate that function. I'm going to call that u dash. The derivative of 3x plus 1 is 3. We're then going to write v, well, v is this function here, x minus 1, and its derivative is 1. Every time you do use the product rule, you're going to do this little side calculation. Now in your working out, you might like to write vertically, you might want to put it in here and then use the product rule, but you will see, personally I like to do it to the side and then apply it directly underneath here. So they're all the elements that we're going to use. So dy dx, the product rule in short notation, uv dash plus v u dash. And all we've left to do now is take these four elements here, because this is my u, this is my v dash over here, I've got my v up here, and my u dash. All we're going to do is take those four elements, substitute them in, and do any simplification or factorization that might be required. So u times v dash, we're going to multiply these two elements together. I'll write it out explicitly, and because I know that I've written it in this order, u v dash, but if we're doing 1 times 3x plus 1, it's usually easier to write the coefficient out in the front of the binomial, plus vu dash. So we're going to multiply these two things here. You might think of that, oh, we're doing it's like cross multiplication. I mean, it's technically not, but it's a way you can think about it if you like. So that's pretty much all we've got to do now, is expand and simplify this expression. Obviously 1 times 3x plus 1 is itself. When we expand this out, we're going to get 3x minus 3. To tidy that up, that'll give us 6x, and that'll be minus 2. There's our first derivative of this function here. I'll just erase some of that so that we can do example 2 here. Just bear with me. Okay, so example 2, we've got these two expressions here. This one's going to be our u and this one's going to be our v. So we've got u dot v. I'm going to call the 9x cubed our u, and we're going to do our u dash. 3 times 9 is 27x squared. We're going to use this one as our v, so v equals 2x minus 7, and v dash equals the derivative of this expression, which is 2. And if you like to think of this cross method, where we're going to multiply this with this and this with this, that can be a good way to think of it. So our product rule, dy dx is equal to u v dash plus v u dash. So multiplying these two functions, 2 lots of 9x cubed plus 27x squared, 27x squared, and this time one of the elements is a binomial, so we'll just make sure we put that in brackets like so. Expand and simplify, so 2 lots of 9, that'll be 18, forget about that, it's not a minus there, 18x cubed, and here this will be 54x cubed, and multiplying those two together, what's that going to be, 140 plus 49, 189, or minus 189x squared. We've got a couple of cubic terms there, and if we add those together, that'll be 72x cubed minus 189, and obviously you get to use your calculator to do those sort of things. The key thing here with the product rule, starting off recognizing that you've got two functions multiplied together. Okay, that means I'm going to use this product rule. Do your setting up, so you get your u and your v, and you just differentiate them, and then bring them back, combine and simplify. Let's go to exercise 6.08 and have a look at question 1, A, B and C, and question 2. So for question 1, we've got these two elements here, so let's go through u dot v. U dash is 3x squared. Our v is 2x plus 3, and our v dash, the derivative of that would be 2. I'll change my pen here. The first derivative then would be u v dash plus v u dash. These two elements together, so 2x cubed. These two elements together, one of them's a binomial, so we'll put the singular one out the front of the binomial. There's the product rule's done, so now we're just simplifying. 2x cubed, expand this expression, 6x cubed, and that'll be 9x squared, and to finish it off, tidy it up, 8x cubed plus sine x squared. That's our first derivative. Part B, I'm going to call this u and this v. So y equals u dot v. U is 3x minus 2. U dash equals 3. V equals 2x plus 1. V dash equals 2. And I'll change my pen again. Y dash uv dash plus vu dash. I'm going to multiply these two elements together, so there'll be 2 lots of 3x minus 2 plus this times this, so 3 lots of 2x plus 1. Expand and simplify. Minus 4 plus 3, that'll be minus 1, and there is our derivative function. Going to be a little bit cramped for room here, but we'll do our best. So we've got u dot v. U is 3x. U dash is 3. V is 5x plus 7. V dash is 5. Y equals u dash, u plus v dash, so it'll be 5 lots of 3x plus 3 lots of 5x plus 7. Tidying that all up would be 15x. Expand this out, that'll be another 15x plus 21, and our first derivative 30x plus 21. On to question 2. Question 2 asks us to find the gradient of the tangent to a curve, this at the point 1, 2. Now the gradient of the tangent, remember, so the gradient using m with a subscript t, that's gradient of the tangent for any function. All we need to do is find the first derivative and substitute the x value of the point that we're given, in this case x equals 1. So we've got the function 2x, 3x minus 2 to the power 4. So we're going to call this our u, we're going to call this our v. Now you'll notice this binomial here is to a power, so we're going to use the chain rule as well as the product rule here. So our u is 2x, our u dash would be 2. Our v is 3x minus 2 to the power 4, and our v dash, in this case, remember the 4 will come out the front, the derivative of the inside will also come out the front, 3x minus 2 to the power 3, and to tidy that up, that would be 12, 3x minus 2 to the 3. Okay, let's combine those. The first derivative, or if you like, the gradient of the tangent, can be found using this function. So it's going to be 2x times this expression plus u dash times v, so that'll be 2 lots of 3x minus 2 to the 4. We're not going to expand, you never expand these out, these expressions, we'll just tidy them up here. So we'll have 2x plus 2x times 12, so that'll be 24x, 3x minus 2 cubed, plus 2 lots of 3x minus 2 to the 4. Now we could do a little bit more factorization there, but if we go back to the question, all we have to do is find the value of the gradient. So we've got the gradient function here. Now we can simply substitute the value x equals 1 into that expression. So if we do that, if we have a look at these binomials here, if we substitute 1 in there, 3 lots of 1 will be 3, take away 1. All this expression here and this expression here will simplify to 1. And this in fact will be 1 cubed, and this will be 1 to the power 4, both which equal 1. So we'll have 24 times 1 cubed plus 2 lots of 1 to the power 4. That's nice and easy. That's going to be 24, that's going to be 2, and so the value of our gradient will be 26. So we could, if we had a little bit more room here, the gradient of the tangent to this function at the point 1, 2 is equal to 26. That'd be a pretty steep line, almost, getting close to looking vertical on a graph. So to practice those, could you work your way through questions 1 to 6. They're on page 307 of the textbook. Exercise 608, remember we've already done, I just did for you A, B and C, but go back and do them again yourself. And I also did question 2. You should be able to get through 3, 4, 5 and 6. Have fun.